Assalamualaikum and greetings everyone. Today's topic is on the tangent vector. Suppose you have a curve in xyz space represented by vector function r, which is equal to fti plus gtj plus htk, and let's say your vector function r is differentiable at t equals t naught and r prime t is not equal to 0. Then r prime at t naught is defined to be the tangent vector to the graph rt at the point where t is equal to t naught. Okay, so here let's say you have a curve. So that let's say that this is your vector function r, which is going to be which is a curve in xyz space. And here we have when t equals t naught, we have a position vector. Remember, position vector starts on the origin, from the origin, and then it stops on the curve. So when t equals t naught, this is where you are on the curve. Okay, this is where you are on the curve when t equals t naught. And r prime at t naught is defined to be the tangent vector to the graph. So at this point, we have a tangent line. So this is our tangent line on this curve, which is that. Okay, so your tangent vector is parallel to the tangent line of the curve at that point. And the tangent vector is represented by r prime. So tangent vector is equal to r prime, where we differentiate r. So if you want to know the tangent vector at point t equals t naught, you just replace t with t prime. So r prime at t naught will give you the tangent vector of the curve at point t equals t naught. Now let's say at t equals a, okay, let's say this is the position vector when t is equal to a. Let's say that this is r at a. That would be the position vector. Then the tangent vector would be, the tangent line would be like that at this point. So the tangent vector would be parallel to the tangent line, but it starts on the curve. So the tangent vector would start on the curve when t equals a, and then it is parallel to the tangent line. Okay, so that would be r prime at a. So r prime at a would be the tangent vector of the curve when t is equal to a. But of course, if you're using different t, let's say at t equals b, let's say this is the position vector when t is b. Okay, so when t is equal to b, you are here on the curve. So the tangent line of the curve when t equals b would be different. So this would be the tangent line. Okay, so that would be the tangent line of the curve at point t equals b. So the tangent vector would be parallel to the tangent line, but it starts on the curve. Okay, so the tangent vector starts on the curve and it's parallel to the tangent line. So that would be, this would be r prime, that would be the tangent vector. So r prime at point b at t equals b would be here. So it starts on the curve and it's parallel to the tangent line. Okay, so given r, a curve in xyz space given as vector function r, then r prime at t equals t naught would give you the tangent vector at point t equals t naught. Okay, so if you replace t with any value, let's say t naught, then that would give you the tangent vector of the curve at that point, at point t equals t naught. So if at t equals t naught you are here, so that would give you the tangent vector at t equals t naught. But let's say your t is b and you are here, then that is the tangent vector at point t equals b. So it differs depending on where you are on the curve. So remember, tangent vector starts on the curve at point t equals t naught here, and t equals a in this case, and t equals b in this case. Okay, so it starts on the curve and it is parallel to the tangent line. That is called tangent vector. How are we doing with time? So we're okay. All right, the next one is unit tangent vector. I will go to this example later. For unit tangent vector, if you remember unit, when you see unit, what should come to your mind is the magnitude is 1. The magnitude is 1. So unit tangent vector is denoted by t, is a unit vector that is parallel to the tangent vector r prime. Okay, so remember tangent vector is r prime, and if you replace t with a certain value, that would give you the tangent vector at that point. Okay, so in general r prime. So unit tangent vector denoted as t is a unit vector that is parallel to the tangent vector r prime of a vector valued function r. So remember, for unit tangent vector, the magnitude is 1. So if you want a vector that is parallel to r prime, but you want it to be in unit vector, what you do is you divide tangent vector with its magnitude. So unit tangent vector is equal to r prime divided by r, magnitude of r prime. Remember, for unit vector, let me refresh your memory on the revision. Where is the revision? Okay, where is unit tangent vector? Okay, item 4. So if you're given a vector v and you want a unit vector that is parallel to in the same direction as v, but you want the magnitude to be 1, so what you do is you take v divided by its magnitude. That will give you a unit vector which is in the same direction as v. So if you want a unit tangent vector, oh, that's not it. 12? Nope. Okay, hang on. So if you want a unit tangent vector, what you do is you take the tangent vector, divide by its magnitude. So you do need to know about this formula. So unit tangent vector is r prime divided by magnitude of r prime. So if you have the same curve like before, so let's say this is your vector function r, and this is where you are on the curve when t is equal to t naught. So r prime at t naught will give you the tangent vector. So the unit tangent vector would be the same direction as r prime, but the magnitude is 1. So it's going to be shorter. So the magnitude is going to be 1. So that would be t at t naught. Okay, so that is unit tangent vector.